Welcome to Flanders AC Solutions demonstration. This demonstration will show the Flanders AC Solution system working against a standard 824 DC motor. The DC unit is positioned on the left and the Flanders AC unit is on the right. The first test being demonstrated is the peak power point. In a dragline process, this is the standard rating of the DC motors. In this test, the point of reference is the kilowatt reading. 1680 kilowatts is the target value, which is the rated peak power of the 824 DC motor. You'll notice by the flashing red box the foot-pounds are just under 10,000. The operating speed is right at 1200 RPM. In the lower left-hand corner we have the DC motor readings. At the bottom is the amperes reading just under 2400 amps with the volts at 673. On a drag line, this is a typical operating point at the high end of the speed range for a hoist, swing, or drag maneuver. The next demonstration is going to show a dynamic response reversal under load from 200 RPM in one direction to 200 RPM in the other direction. The blue line indicates the speed of the motor dropping from 200 to 0 and back. The green line shows the torque reversing from one direction to the other, and the red line shows the kilowatts as the reversal happens. You'll notice the quick response time as we see the readings change with the direction of the motor. As we repeat the test, notice again the quick response time as the motor direction changes and the shaft quickly stops and accelerates back to the 200 RPM in the other direction. This is simply a demonstration to emphasize the quick response time of the Flanders AC Solution system. The next test that will be demonstrated is the peak torque or stall torque that is created during the drag function as the bucket is being filled. The point of reference is the 5000 amps of the DC motor and the torque developing on the shaft between the DC and AC motor. As the load is started, we see the current building to 4700 amps and the torque in the upper right hand corner at approximately 26,000 foot-pounds. What this demonstrates is the AC motor is capable of developing the equivalent torque to the 824 DC motor. This is a repeat of the test showing similar values of 5,000 amps and nearly 27,000 foot-pounds of torque. The following photo sequence are instructions for power modules installation. Be sure to follow the appropriate lockout, tagout procedures and verify safe working conditions before conducting any electrical work on the drive system. This is a power module ready for installation. Ensure that the guide pins are aligned to the positioning slots. Gently lift and slide the module into place, ensuring that the locator pins are fully seated. Insert mechanical connection bolt through the mounting plate. Using a wrench or socket, secure the bolt and torque to specification. Install upper and lower bolts to the DC bus bar and torque to specifications. Order of installation is not critical. This photo shows the second bolt being installed into the DC bus bar. Here we see both of the DC bus bar bolts installed. This photo shows the AC bus bar connection with a single bolt. Install the control connector to the module as shown in this photo. The installation of the module is now complete.